Hello everyone. So this video is going to be about introduction to data structures and algorithm. Okay. So let's take this example. Okay. So here we can see two pictures. Let's take the first picture. Okay. So in this picture, we can see a room with a messy clothes, some things was randomly placed in different locations. Okay. For example, if you want to find a key in this particular room, it will be really hard for you, right? So it will take few minutes, few seconds, who knows, maybe few hours as well, right? So if you see the second image, okay, if the room is organized like this, what you can do? So you can easily find the things, right? So within a few minutes, not even a minute, within few seconds itself, you can find because everything was organized properly, right? Like the same way it is applicable for data as well. A data should also be in a structured way. Then only we can able to get the data in a very fast manner. Okay. So now what we are going to do? So we are going to see what is data structure, what is algorithm separately. Okay. So then we will see the difference between both of them. So in this picture, if you see here, so we are going to understand what is a data structure. A data structure is simply a way of organizing a data. Okay. So in this picture, if you see here, if you organize your books like this, okay, so it will be really hard, right? So if you want to find one particular book, what you need to do? So you need to see all the books one by one, again and again, you need to do, right? But if you see here in the right side image, so in the right side image, everything was organized based on some year, some edition, or some alphabetical order. Okay. So if you keep your books like this way, it will be really easy for you, right? It will be really easy for you to take the books from the place with where you want. So which book you want, you can take directly. So no need to waste time, right? You can save time. So you can take it very fast manner, right? Like the same way, this is a high level example of what is a data structure. Okay. Now what we are going to do? Now we are going to see what is an algorithm. So if you see here, what is an algorithm? The algorithm is a sequence of steps. The sequence of steps is an algorithm. Okay. So for example, you are in a class. Okay. You are in a class. You are sitting. Okay. So you want to find your friend. Okay. So while going, you want to find your friend. What you will do? So you will first check the row 1. Then you will check the row 2. Then you will check the row 3. Then you will check the row 4. Like this, you will go in a sequence, right? A sequence of steps is an algorithm. Okay. So this is what does an algorithm means in a high level. So let's move to the next one. So if you see here, the next one is why we need to learn DSA. Okay. So first, take one example. So take one mobile phone. Okay. So for example, there is only 10 contacts in your mobile. Okay. So if you want to find one number out of this 10, you can easily scroll and you can find, right? So you can easily scroll and you can find. But for example, if there is 5,000 contacts, okay, it will be really hard for you to manually scroll and find, right? So this was a problem. If you manually scroll and find, it will take a really long time, right? So you want to avoid this thing. So here comes the data structures and algorithm. This data structure and algorithm will help you to find the contact very fast. So it will increase the speed. So you don't need to waste that much time. Okay. So here this data structure and algorithm help you to solve this particular problem. So now let's see what is the difference between data structure and algorithm. Okay, a difference between a data structure and algorithm. So now we can see this one, right? So the first image, let's take this as a kitchen. Okay, so if you want to do cooking, so what you will do? So every ingredients will be in a different containers, right? So you are going to do cooking, so that you need the ingredients, right? Without the ingredients, you can't able to cook. So we are having the ingredients. So what we are doing? So we are storing those ingredients in a particular containers, right? So this is known as a data structure. In the second image, if you see a woman, she is reading the instruction. Okay, she is following the instruction and she is cooking, right? So she is using, first you need to put this ingredient, then you need to put this ingredient. So you need to stir for some time. So she is following an instruction. Okay. So this is known as algorithm. So this is a real life example, a high level idea between a data structures and algorithm. Now we are going to see little bit technical. Okay. So a difference between a data structure and algorithm. So a data structure which is used to organize and store the data. Okay. Whereas this algorithms, this is used to solve problems step by step. Okay. So here you can visualize the previous example to store the ingredients in a container, to follow the instructions step by step, right? So the next one, focus on data management. So this will focus on the data management, whereas this algorithm thing will focus on logic and operations. Okay, so this is the key difference. The data structures which had been used. Okay, so we can give an example for data structures, arrays, trees, graph, we can give an example. But whereas an algorithm, we can tell binary search, merge sort, quick sort, like that. We can tell those things as an algorithms. So we will cover these things in a later videos. Okay, don't worry. So DSA, data structure and algorithm. So data structure, we are going to store the data. Algorithm, we are just going to process the data. Okay, so arrays, stack are the example. So here searching and sorting. Let's move to the next one. A data structure. So we can split the data structure into two parts. So one, which is a linear data structure, and another one is a non-linear data structure. Okay, a linear data structure, you can split this into four parts. Arrays, stack, queue, linked list, like that you can split. Whereas a non-linear data structure, you can split into trees and graphs. Okay, so we will see one by one in an upcoming videos. So now we are seeing about real life examples, where we are using data structures. Okay. So every day we can use Google Maps, right? So this Google Maps internally uses graphs. Okay. By using graphs, we are able to find the nearest location. So there is an algorithm, different algorithms to find the shortest path between one location to other location. So here in Google Maps, they are using graph. Okay. Whereas in Google, if you are going to search something, right? So if you want to search something, then it should come in a millisecond, right? If it takes more time, so the users won't be again come and search in the same platform, right? So Google uses a very efficient sorting algorithm, efficient searching algorithm to find an element. Okay, so to find an element, to find a page, to find a website. So Google is internally using some efficient sorting algorithms and searching algorithms. Okay, the next one, a social media, Facebook, Instagram, WhatsApp, not a WhatsApp. So Facebook and Instagram. So they are using a graph internally. Okay. So what it will do. So for example, you connected with the person A, and A and B, both of them are connected. Okay. So B is connected with C, but in Instagram or in other social media platforms, what they will do. So they will show the C as your suggestion. How it is coming? Because of graph. Okay. So internally they are using graph in social medias. And coming to this fourth example, which is a database. Okay, internally in database they are using this tree. Okay, by using trees they can able to get the element very fast. Okay, so in database they are using trees. And coming to the next one, this one. So here they are internally using stack for the undo feature. Okay, so for the undo feature they are using stack. Okay, so these places data structures had been used. Let's move to the next one. Interviews. Okay, so this is a very important one. For example, there is one question. Okay, question one. Okay, so there are two person one and person two. Okay, so person one solves the question. So both of them solve the question. Okay, so both of them had given one solution. So person one's solution takes 5 seconds to run. Okay, but whereas person two's solution takes only 2 seconds to run. Okay, so the interviewer will choose this person. Okay, so for one question there may be multiple solution, but the solution which is taking very less amount of time, the very less amount of space. So that solution is an efficient solution. So internally, this person used many data structures and different algorithms. Okay, but whereas this person didn't use anything. So he used a particular data structure and a very efficient algorithm to solve a particular problem. Okay, so the interviewer will select this candidate. So because of this, so you need to learn data structure. The next slide, this is all about a beginner mistake. So what mistakes beginners they will do initial stages. Okay, so what they will do if they are seeing one problem, okay, instead of understanding that problem, they will memorize the solution. Okay, if you memorize the solution, you can't able to solve the problem. You can memorize the solution. If the same question comes in an your interview or some coding interview, you can directly copy and paste and it will work. But for example, if they make a small change, so instead of they are telling 1, 2, 3 need to add. So instead, if they are telling you need to multiply 1, 2, 3, so you will directly copy and paste the same solution, right? But the changes you just need to change the operator. So this is a simple example, right? So you should not memorize the solution. You should understand the solution. You need to practice more and you need to regularly solve the problems. Okay. So this thing you need to avoid as a beginner. And the preferred learning order. Okay. First, you can start with basics, some for loops, if else like that. Then you can move to arrays, then strings, then stack, then queue. Then you can move to linked list. So then trees, graph, and dynamic programming. So like this way, if you go, it will be little bit easier for you to cover all the topics. Okay. And the last one, okay, a tip. So DSA. Okay. So before going to the DSA thing, so take this example, gym. Okay. If you want to get your dream physique, a dream fit, which you want to looks like, right? What you need to do? You need to go to gym. Think if I go to only one day, okay, I just exercise for 24 hours. Can I able to get the dream physique like this? No, right? So every day I need to go. Every day I need to go to gym. Every day I need to follow the diet. Every day I need to do eat some proteins and I need to consistently do the exercise, right? So then only I can able to get the dream physique. Like the same way, in one day, you can't become a DSA expert. In one day, if you solve 100 problems also, you can't able to become a DSA expert. Because every day consistently you need to solve problem. Okay, so in DSA the number of problems how much you solved in a particular day, that doesn't matter. How consistent you are, so that is matter. So in DSA consistency is key. Okay, so consistency always beats intensity. Okay, so regularly give problems, regularly solve problems, regularly practice problems. Okay, and that's all about this video. Thank you all. So see you in the next lectures. Bye.